Find angular acceleration alpha dependence on theta.
So what is a spool?
Yeah, I'll come to that. Yeah, I'll come to that. You must have seen by the side of roads, there is a structure which has got two discs and a cylinder on which wire, generally nowadays you will find optical fiber cable. Optical fiber cable is wound. I'm talking of this structure. Twine, you know twine, Krish?
Mm,
You know
mm,
twine you use for kite, to
oh,
fly
yes, sir.
kite?
Yes, sir.
Okay, so similar to twine structure, you have disc to secure winding, and winding is being done on cylinder. Is it okay? You must have
Yes, sir.
seen this structure. I can see one just out of the window. There is one kept by the side of road. So there are two discs, and the discs are separated by a cylinder, you can say. Discs are of radius in the case that I am referring to. My disc is of radius capital R. Is it okay?
Yes, sir.
The disc that I have taken, the two discs that I am speaking for, they are of radius capital R, and the inner disc is of radius small r. Is it okay, Krish?
The inner
Inner disc,
yes,
or
sir.
not disc, in a cylinder is of radius small r. Find yeah?
Yes, sir.
Okay, got it. What a spool is, first of all.
Yes, sir.
Okay, so this is the structure which I am referring to. I'm taking the side view of it. So this is spool to me. And here you have got two radii to refer to. First radius, sorry, is capital R, and second radius versus small r. So there are two radii, and I presume you can relate to them, correct? Yeah.
Yes, sir. Yes, you're taking a cross
There are
section
two
of it.
radii, and we can relate to them. Small r is to relate to cylinder, and capital R is to relate to disc, correct? Yeah.
Yes, sir.
Capital R relates to disk. And what is the purpose of disk being there? To secure windings. Correct, yeah?
Yes, sir.
So you can keep on winding layer after the layer till capital R. Correct, Krish? Correct, Adesh?
Yes, sir.
Okay, so that is what is called spool or twine, as we call twine. In kite, if you want to purchase, you have to go and ask for twine. Twine is of this structure, correct? Can you recollect?
Yes, sir.
And this is what we rolls for the string to get wound. Correct? Yeah, correct, Krish?
Yeah, yeah, yes, sir. Yes, I got now.
Exactly the same structure, barring these sticks. These holders are removed, these sticks are removed. This is spool to me. Small r is the radius of cylinder, and capital R is of disc. Correct? There are two radii which any spool will relate to, and the two radii are being shown to you. Now what being asked of you is, when you pull string which is wound, of course string being wound, what you do? You pull string, correct? Yeah. So when you pull
Yes, sir.
string, then string which you are into pulling, as it is wound on cylinder, the direction of tension or the string orientation will be perpendicular to small r. Agreed?
Yes, sir.
As you are trying to pull, wherever from you do pull, Krishnadesh,
Yes, sir.
wherever you apply the pull force from, you apply along this line, you apply along this line, whichever line you take, one thing we are to sure rest on, and that being the string orientation will be perpendicular to small r. Find yeah.
Yes, sir.
Yes, sir.
Okay, because string will come out, the string will unwind, taking what angle with small r, making what angle with it? Making an
90
angle
degrees.
90 degree. So no exception over here, this angle must be 90. Anyway, what being given to you is theta, this is theta. Theta being given to you, by that what I mean, angle that string orientation makes with horizontal. Find yeah.
Yes, sir.
Yes, sir.
Angle that string orientation makes with horizontal is being given to you, and that is theta to us. Now you are trying to pull string. As you are trying to pull string, What happened to point of contact? What happened to point of contact? In which direction the point of contact will start moving according to you? Because initially there is no motion allocated to it. See, both the motions, rotational as well as translational, both the motion, rotational as well as translational, they will be after effect of your pull. Correct, yeah?
Yes, sir.
The motions, rotational as well as translational, they will be ramification of your pull, after effect of your pull. So you pull, and as you pull by a force F, let us say OT, what you see that this T or the component of T cos theta will give spool a translational leaning, correct?
Yes, sir.
Think about it. T cos theta, I'm talking of T cos theta first. So T cos theta will get the spool a translational leaning. That means T cos theta will be to the right. T
Yes,
cos
sir.
theta will be to the right. Yes or no? Yeah.
Yes, sir.
Not
Yes, sir.
T cos theta to the right. That was a fag and a rotational topic. Very important topic this. Today we'll see and then check it. Check it out. Is it fine?
Yes, sir. So what is theta? So theta is the angle made with.
Yeah. Krish, wanted to ask something?
Yes, sir. Theta is the angle made with horizontal, no, sir?
Yes, theta is the angle that string orientation is making with horizontal. Correct, yeah?
Yes, sir.
Okay, now tell Krish, if I ask you to write motion related to center of mass, how many forces or components of forces you are to pay heat to? You will say you will pay heat to T cos theta and force of friction, correct?
Yes, sir.
Because T sin theta, as you can see for yourself, will be in the direction vertically upwards. Fine, Krish? Fine,
Yes,
Adesh,
sir.
Vedant.
Yes, sir.
So T cos theta is the only component which can tantamount to translational leaning. Can we say that?
Yes, sir.
Okay, so T cos theta will give it a translational leaning, and also T per se, T in totality will give it a rotational leaning. Think about it. T cos theta will get it a translational leaning,
Yeah.
but
Yes, sir.
T per se, T in its entirety will get the body, get spool, rotational leaning. Think about it here.
Yes,
Please
sir.
take a note
Yes.
of it. Because these questions are, though questions taken from revered books, but they are taken part of theory and you can get improvised questions. By that what I mean, you can get questions in matrix form by getting you different value of theta and accordingly asking you questions which are incommensurate with the value of theta given. Correct, yeah?
Yes, sir.
Yes,
I'll
sir.
come to it. I'll come to it. But first, let us read in wholesome the concept related to it in its entirety, in its finality. Check there. T cos theta is to get us a leaning to the right. Body will get a leaning to the right. And what leaning is that? Translational leaning. Then I come to T. When I come to T, I find T being perpendicular to small r, correct?
Yes, sir.
Yes.
And if T is perpendicular to small r, that will not about the axle of spool, which is this point, will not about the axle of spool, which is O, will not about O. T produce a rotational aspect or effect.
Yes, sir. It will produce.
Yes, sir.
Will it produce a rotational effect? Will it have a rotational aspect to be looked after? Yes or no?
Yes, sir.
Yes, sir.
And what will it be? Tell me the torque about O due to T. Please be careful. Tell me the torque due to T about O. Angle that is making with horizontal is theta, mind you. A reminder. Angle that is making with horizontal, T is making with horizontal is theta. Though I am asking you what torque T will produce about O.
Sir, out of the board.
Out of the board, R cross F, out of the board. And what will be in magnitude? Yes, out of the board, accepted. Good, Adesh. What will it be in magnitude, Krish?
It will be RTTR.
Will be T into R. Very good. Because they are perpendicular to each other. Generally, students do commit a mistake over here. Good, you kept yourself alienated from it. Why I'm saying you good, you kept yourself alienated from it. 99% of the case student, what they took, I have seen what they took was T cos theta. Of course, T cos theta will never feature in rotational equation. Correct? Yeah.
It's a component.
Yes,
It's not.
sir.
Yes. So what will feature? T in its finality, totality is to feature, and that will get us T into small r equal to I naught into alpha. Yes, please be mindful of the fact that this torque is trying to rotate body in sense anti-clockwise, correct?
Yes, sir.
In sense
Yes,
anti-clockwise.
sir.
Getting it or not? Think about it. Think
Yes,
about
sir.
it. Yes or no?
Yes, sir.
Okay, so this tension about tries to rotate body in sense anti-clockwise. I didn't get a yes from you, Krish. Any confusion?
I told yes. Yes, sir.
Okay,
Yes, sir.
fine. So that is trying to rotate. Though I cannot be oblivion to friction. So I'll come to friction and then this equation will be written in its complete sense. For now, this equation is bereft of friction. But we are no ignoramus to friction. Certainly there will be friction. I'll decide on direction of friction. But I need a hand of help. Could you please stretch a hand of help? Could you please let me know friction will be at the point of contact seen to act or not? Friction
Yes,
will be
sir.
at point of contact seen to act or not, firstly. And if you are to say that it will act, if you are of the opinion it should act, then will act in which direction? But first things first, will it act or not? Will it act at point of contact or not? When it doesn't act, when there is no acceleration related to that point, correct? Yeah.
Yes, sir.
Okay. Now think of the rotational aspect. Rotational aspect is giving this point an acceleration in the forward direction alpha r. Think about it. Think about it. Think about it. Yes or no?
Yes, sir.
Yes, sir.
This point will have a tendency to move forward, correct? Yeah, and move
Yes.
forward with
Yes,
alpha r. For the first time, you are getting alpha r in the forward direction. Please mindful. Please be mindful of the fact. Please pontificate and take a note of it. Okay.
Yes, sir.
Please pontificate that rotation is anti-clockwise, and in accordance, alpha r will be to the right. Correct? Yeah.
Yes,
Yes,
sir.
sir.
Please take good note of it. Alpha r in the forward direction. Good. Now we go for the translational aspect. And translational aspect again bereft of friction will get me T cos alpha is equal to MA. Correct?
Okay,
So
yes, sir.
one
Yeah.
second.
In
Yes,
bereft
sir.
of friction. I told you I don't know anything about friction. We need to decide. And when we decide, we absolve ourselves of friction consideration. Correct? Yeah.
Yes, sir.
Yes, sir.
Yes,
Which I
sir.
have not. So there. Nowhere I have taken friction into account as we are to know friction will act or not, and if so, in which direction. After of that only, I'll be writing my equations in their totality. Correct? Yeah.
Yes,
Yes,
sir.
sir.
Okay. Now T cos theta is in the forward direction. So A will be in which direction? Goes without saying. Please tell me. A will be in which direction? Tell me, yeah. Tell me as
Yes.
per the schematic diagram. As per
In the
the
forward-
schematic
Forward
diagram.
direction.
All of you please, come on now. A will be in which
Forward.
direction? Come on, all of you. I want all of you to respond.
The forward.
Forward direction.
Forward.
Vedant, A will be in which direction?
Forward.
Forward. R forward. A R forward. Correct, yeah?
Yes,
Yes,
sir.
sir.
Alpha R forward, so is AR. Therefore, what can we say about acceleration of point of contact? A plus alpha.
Plus alpha.
In which direction? I cap, right here.
Yes,
Yes,
sir.
sir.
As it is in the direction I cap. Force of friction will act in which direction? Come on, dear. Come on,
Minus
dear.
I cap.
Backward. So minus
So
I cap.
backward. So backward.
the direction of force of friction, and we need to now seek author's permission. I will ask author, will you allow rotation or slipping, or am I to take it without slipping? Author in Ayurveda says that it doesn't slip. Is it okay? What does the author say? That it doesn't slip. And if it is not slipping, then which force of friction is that? Fs, right? Yeah.
Yes, sir.
Force of friction will act Fs. So friction will act, of course, but which force of friction? Not Fk, Fs. Correct?
Yes, sir.
Now help me write in its form and manifestation. Help me write this equation in its form and manifestation, in its entirety, in its totality. Help me, dear. Help me. Now factor in friction, correct?
Yes, sir.
Now we will factor in friction. Say yes or no?
Yes, sir.
Yes, sir.
Okay. So what shall I write? Fs into which R? Small r, capital R.
The capital R.
The capital R.
Capital R.
So Fs into capital R minus T into small r. Correct, yeah?
Yes, sir.
Yes, sir.
Equal to what to us? Is equal to I naught into alpha. I can take alpha in whichever direction I deem. I'm assuming Fs to be greater than TR. It can be less as well. Is it okay? It absolutely goes as per your perception. Am I clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So I'm assuming that it will start rolling later, and how, as for me, it will have an inkling to rotate in sense clockwise. So Fs is to me, Fs into R greater than T into R. Okay, no issue. Second equation. A is equal to capital R into alpha. Will you approve of this as well? And there is no rolling.
Yes, sir.
Yes, sir. Yes, sir.
Without slipping. So this is no
Yes,
rolling
sir.
with slipping, correct?
Yes,
Yes,
sir.
sir.
No rolling with slipping. A is equal to R alpha will follow, right? Yeah.
Yes, sir.
Yes, sir.
Now the translational aspect, please. Translational aspect. Complete this equation as well. T cos theta forward and what backwards? Fs, correct?
Fs.
Yes, sir.
Yes, sir.
Theta minus
Minus
Fs
Fs.
is equal to mass into acceleration, right? Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good enough. Now, with the help of three equations, get me alpha. All of you, please do the needful. With the help of three equations, 1, 2, and 3, get me alpha. Please get yourself free of Fs, as Fs is an abstract force, correct? Yeah?
Yes, sir.
Okay, so we can't say everything is honky-dory with Fs being around. Nothing can be honky-dory with Fs being around because Fs itself will keep on changing colors. Correct, yeah? Chameleon,
Yes,
correct,
sir.
yeah?
Yes,
So
sir.
we need to get rid of chameleon. Fs should be off our consideration. Tell me how will you get yourself rid of it? I think you are capable enough, right? Yeah.
Yes,
Please do
sir.
the need.
Yes, sir.
Get me answer.
So do we replace I naught by gamma mr square?
And you can place Krish. For those who joined late, I naught for the structure was given to you. It is gamma into m capital R square, right, Krish?
Yes, sir.
Where gamma is greater than 1. This author gave you. Because this structure,
Yeah.
gamma, I naught, of course, is difficult to find. So I naught was given furnished by the author. Find ya?
Yes, sir.
Yeah. Sir, I'm getting very weird answer. It's not normal. Sir, I'm getting
Get weird answer.
Sir, I'm getting T into R, capital R cos theta.
Okay, alpha is equal to T into
Okay, alpha, no, sir, sorry, I made a mistake. Yeah, yes, sir. T into
What?
capital R cos theta minus small r
Okay.
divided by mr square into 1 plus gamma.
Okay, just asking, can we reshape it to this form, dear? E cos
Yes.
theta small r by capital R, right here, divided by 1
mr
plus gamma R square. Is it so? Just check. I don't know. I'm not very sure.
1 plus
1
gamma
plus
r.
gamma. Check, dear.
Yes, so
Just check. Check once.
Sir, M will have to feature, no, sir?
M will feature, right? Can feature, no issue. M will have to feature. So tell me, what will it be? What will be the denominator? Numerator, I'm sure of. Denominator, you can help me on.
Yes, sir.
I think M should be outside and 1 plus some. Check once.
1 second, I'm getting something else. I'm getting MR plus MR gamma.
MR plus MR gamma. Fine, it can be. But which R? Which R? Capital R.
It's a capital R only, capital R.
Okay, MR plus MR gamma. Correct, yeah?
Yes, sir.
So I can take MR outside. Correct?
Yes, sir.
Is it fine? Check once. Check all of you.
yes.
Is it what we are getting, all of you? It's an I of question. Check the answer if you have I of around. If you have I of around, check the answer.
The question number?
Question number, wait, let me tell you. This is 1.257.
1.257.
1.257.
Yes, sir. I'm seeing.
Page 52.
Yes.
Check the answer. Are you getting it? F
The one.
cos theta 1 by small r by capital R. Yes, Adesh.
So I'm bringing. I didn't get it. I got a very weird answer.
Okay,
Kind of
answer.
different.
There's nothing much left, by the way, in this. Anyway, if you're not getting the answer, you can figure it out. M gamma MR square Fs I'll replace from here. And
Yes, sir. I
A
did that.
because I want alpha. So A will be replaced, alpha is required, and Fs will be replaced as well.
Yes, sir.
That'll give you the end result. That's not much to get from there. I'm just skeptical of what is in denominator. Could you please help me with denominator? Yes, Krish.
Sir, I'm seeing the answer, sir.
Denominator. Are you getting the same Krish in denominator? What is the reflecting the answer? Check the
I'm seeing the answer, sir. I'm searching for it.
So which
1
sum
point.
is it?
So 1 point.
I told you the number, man. 1.257. .257. What
Sir,
happened
the
is right?
answer, so the answer is it's for omega x is given, sir.
Omega?
Omega is given for omega. It's not.
What Krishna? Oh, I see. How can it give for omega, Krish? Omega will keep on changing anything. 1.257.
So omega
So
x.
the
For me, it's
What
a very,
is
when is the terms of
wrong.
E?
I go.
1.257? Where is it? That omega is alpha only, Baba. That omega is alpha only. They have used alpha as angle. Okay, that is angular acceleration only.
Okay, sir.
Okay, that is angular acceleration.
Okay. Okay, sir.
Since they have used alpha there in the question as angle, so they have not used alpha, they have used omega as symbol. But that is angular acceleration. Find here.
Yes, sir. Yes, sir.
We got
So
this
the,
only. R is not to be seen. R is an extra in denominator, correct?
so the answer is f into cos alpha minus
I can
small r
see.
by capital R divided by m into 1 plus gamma.
Is this R there in your calculation? Is this R there in your calculation? Check.
Sir, which edition do you have if I rid of CBS?
CBS, this CBS book and edition must be old. Why? Yeah, they have
No,
not
because for
put
me
a thing in it.
it's completely different.
So that must be Aryan then. CBS, is it
No,
CBS?
sir, CBS only, 10th edition I have.
1.257, did you check?
Yes, sir, it's the Earth one with the satellite and all.
What? You say? Then
Yes,
you
sir.
check for rotational dynamic portion. What have they marked? Rotational dynamic. What have they marked? Rotational dynamic 1, 2, 3. Check that first.
Yes.
257 will remain the same. Generally, they change the first digit as per what is their order of preference.
For me, it's fundamental equation of dynamics.
Okay, and what is enough? Just check the figure. This figure must be there somewhere.
Okay, yes, sir.
Question comes with a figure. It comes with a figure. Check there. It's fine. Did you get it? Are you able to spot it here?
Hmm.
Adesh, are you able to locate the question?
No, sir, it's a very different book from the order is different.
Are you able to see this figure anywhere? This figure?
Yes, sir, I'm seeing.
Check the figure. Visible?
Yes, sir, I can see the.
Check the
Okay.
figure in your book. Got it? Not?
No. So the name of the book is Problems in General
Fine,
Physics,
yeah.
right? That only.
Yeah, it is Problems in General Physics. Show
I
me your book.
Yes. So 1 second.
Fine, it is okay. That's correct.
Yes, sir.
Check the first few pages, no? First 100 pages you check. Align the first segment.
So this is the
Rotational
contents also.
No, forget about the content. You first 10 pages you check. 10 or 20 pages. I think you'll get there. First 10, 20 pages you should get there. Not getting? I'll let it be then. Fine, you check later. I'll figure it out where it is. For now, the answer. Krish, you got the answer? We are getting this
Yes,
as
sir.
the answer. Adesh, we are getting this as the
Yes,
answer.
anyway.
After our simplification, we get alpha equal to t cos theta small r by capital R. On purpose, I have divided by capital R because I don't want in denominator capital R to feature. Krish was telling
Yes,
me
sir.
about small r cos theta. Krish was telling me about capital R cos theta minus small r perhaps. Check Krish.
Yes, sir. Yes, sir. Same thing. But then, yeah.
Capital R cos theta
Yes.
minus small r divided by m1 plus gamma into capital R, correct?
Yes, sir. Yeah.
I wanted denominator to be free of capital R, so what I have done, I have divided numerator and denominator by capital R, correct, yeah?
Yes, sir.
And there
Yes,
is
sir.
also some hidden motive for the same. There is some hidden motive. I'll come to that and double later. For now, this is equation all of you incommensurate with t
Yes,
bracket
sir.
of cos theta
Yes,
small
sir.
r by capital R in the denominator. M into 1 plus gamma. That's it.
Yeah, yes, sir.
Yes.
Yes, sir.
Yes, sir.
Okay, good enough. Now coming into what I was trying to get from here. Now I'm coming to what I was trying to get from here. So I diverge. Look at your equation, class. Look at your equation and read alpha for clockwise, anti-clockwise, and zero values. When will get you clockwise values the alpha? The equation of alpha, when is to get you clockwise values? When cos theta is greater than small r by capital R. Agreed?
Yes, sir.
Yes, sir.
Denominator cannot be negative. Are you getting it? Denominator cannot be negative, as denominator is 1 plus gamma whole multiplied with m. So that cannot be negative. Numerator can be positive, negative, and 0 as well, right?
Yes,
Yes,
sir.
sir.
So when can numerator be positive? When cos theta is greater than small r by capital R, right dear?
So alpha
Yes, sir.
clockwise.
Yes dear, cos theta. Cos theta is greater than small r by capital R, right dear?
Yes, sir.
Yes,
Yes,
sir.
sir. So this is a condition for alpha.
R by capital R, then this spool is to rotate clockwise. Can I say that? If cos
Yes,
theta
sir.
is greater than small r by capital R, then this spool will rotate clockwise, in the sense clockwise. Agreed?
Sir, isn't
Yes, sir.
clockwise negative and anti-clockwise positive like that?
Nothing anti-clockwise, positive, negative, dear. Alpha I have taken Krish clockwise, correct?
Okay, yes, sir.
You
Yeah.
got the answer of alpha for
Okay.
this positive, correct, dear?
Yes, sir. Yes, sir.
So sticking to this, you can take the other way around as well. You will then get for that positive, correct, dear?
Yes, sir.
Yes, sir.
As alpha was taken this orientation on with, and I am sticking to it. Alpha with the same orientation on will get me positive when cos theta is greater than small r by capital R, correct?
Yes, sir. Yes, understood.
Yes,
Yes,
sir.
If
sir.
cos theta is greater than small r by capital R, then the alpha that I have taken is what the question is yielding, correct?
Yeah, yes, sir.
Yes, sir.
Okay. On contrary, if I get cos theta less than small r by capital R, then I get alpha
Sir.
negative, correct?
Yes,
Yes,
sir.
sir.
Yes,
Get this
sir.
equation. Then I get alpha negative, correct?
Negative. Yes,
Yes,
sir.
sir. So, and
Alpha, when you decode that negative, what you ought to say? That alpha is not in a direction that we took positive, it is in the direction opposite to it, correct?
Yes, sir.
yes, sir.
So sense of alpha will be then anti-clockwise, right, Krish?
Yes, sir.
Yes.
Yes,
All Krish?
Yes, sir.
Sure?
yes, sir.
Yes, sir.
Yes,
Yes, sir.
sir.
Okay. Can I also meet a situation in which there is no alpha at all associated with the body taken, it only translates?
Uh,
Yes.
yes, sir.
Yeah.
Of
So,
course we can.
so
When cos theta is equal to small r
equal
by
to,
capital R, correct? Yeah.
yeah, yes, sir.
Yes,
If
sir.
cos theta is equal to small r by capital R, alpha will be 0, but certainly the body is to translate, correct? Yeah.
Yes,
Yes,
sir.
sir.
Yes, sir.
In the case when we are equating cos theta to small r by capital R, we get a pure translational motion exhibition, correct?
Yes, sir.
Yes, sir.
Got here, got all of you?
Yes,
Yes,
sir.
Yes,
sir.
sir.
We can ask you in matrix form this question. Cos theta less than small r by capital R equal to small r by capital R greater than small r by capital R. And you see over here something which doesn't, as for me, is not something which is that easy to stomach. Why I'm saying it is not that easy to stomach? Because the comprehension is difficult. What comprehension is difficult? You are pulling it and it is rolling towards you. Okay? You pull
Yes,
it and it
sir.
rolls away from you. That is organic, correct? Yeah. I pulled
Yes, sir.
and it rolled away from me. Fine. That we understand and relate to. But if I'm pulling and the spool is moving, rolling towards me, that situation is slightly weird. But mathematically, we have proved that that also can very well get exhibited. For what value of theta or cos theta? When theta is cos inverse, small r by capital R, right here? Or
Yes,
cos
sir.
theta is greater than small r by
Small r by
capital R,
capital R.
correct?
Yes, sir.
Yes, sir.
Okay. Am I good with this question, class? All of you? Krish, Vedant, Adesh?
Yes,
Yes,
sir.
sir.
Shall we move to the other questions?
Yes, sir.
Yes, sir.
Okay, good enough. Write down. A plank of mass capital M. A plank of mass capital M has a flank of mass capital M has a sphere of mass, a sphere of same mass, make it a sphere of same mass, a sphere of same mass rolling without slipping on it, rolling without slipping on it. Plank being kept on a smooth surface, plank being kept on a smooth surface. Find equation of motion. Find equation of motion, hence alpha. Find equation of motion, hence alpha.
Sir, I have a question. The static,
Yeah.
sorry, the friction coefficient is 0, right?
Friction
Not this
coefficient
number.
between plank and ground is 0.
Yes, sir.
Between plank and ground is 0. Certainly it cannot be 0 between sphere and plank, correct?
Yes,
Yes,
sir.
sir.
If it is 0, then sphere can never exhibit rolling without slipping. Rather, it will never roll, correct? Yeah.
Yes, sir.
Yes, sir.
Can roll if you apply force, otherwise it will not. Find yeah.
Yes, sir.
Yes, sir.
Okay, so I have applied force over here F, and there is enough mu to arrest slipping. Mu between, there is enough
Sphere and plank.
slipping.
Sphere
Mu
and plank.
between plank and sphere, correct? Yeah.
Yes,
Yes,
sir.
sir.
Very good. Now, look at the situation at disposal and help me with few questions which I do have for you. Question number 1. If I apply force, whatever be it on quantum, whatever it may be on quantum, if I apply force, then owing to that application, what will happen to system per se? Owing to the application of force, how will the system respond?
So the plank will move backwards.
You're saying something. Yeah, please complete. Yes, Adesh, please complete. Go on.
So the plank will move backwards.
Okay, maybe, I don't know. I am asking you to take this a system. If you take this a system, you don't know what are the component of this system. Are you getting it?
Yes, sir.
Yes.
You don't know what are the component of the system rendered. You have been rendered with a system, correct? Yeah. Someone did
Yes, sir.
tender you a system. And the person who is tendering you, that person kept from you what component this system is made up of. Am I clear?
Yes, sir.
Yes, sir.
Okay. He has simply tendered a system to you. And on that system, when the system is kept on a smooth surface, you apply a horizontal force. Am I clear?
Yes, sir.
Yes, sir.
So when you apply a force horizontal on a system which is kept on a smooth surface, what is going to be the ramification of that force application?
So the
So the
system should
system
move.
will towards the
System
force
will start
moving
Should move in the direction.
towards.
Yeah.
System will start moving, right? Yeah. Moving in
yes,
which direction? In the direction of application of force. I mean,
application of
yeah.
force. Yes, sir.
Yes, sir.
Adesh, are you getting it, Adesh?
Yes, sir.
I have a system, Adesh, which is kept on a smooth surface. Whatever it may be made up of, whatever component must be there going in forming that system, I applied a force. Only one force is what this in horizontal direction, at least. In the horizontal direction, if my concern is only horizontal direction, there is only one force is being subjected to, right? Yeah.
Yes, sir.
Solar force, the unilateral force, yes or no?
Okay, yes. Got
And
it.
then the body will start accelerating. What
Yes, sir.
acceleration are you associate with body? F divided by twice of M. Agreement of your
Yes, sir.
Yes, sir.
Yes, sir.
agreement
Yes, sir.
Yes, sir.
divided by 2M. This is the acceleration with which body, the system per se will start moving. And if it starts moving with this acceleration, then what will be the effect of this acceleration on rotational and translational equation of sphere? Correct? Yeah?
Yes, sir.
Yes, sir.
That is what we are to, as we always do, right, for rotational and translational aspect of given body. Correct? Yeah.
Yes, sir.
Yes, sir.
Let me ask you, shifting my focus to sphere, let me ask you, according to you, how many forces will act on sphere? You will say one being applied, the other normal mg, and yet one which is force of friction,
Friction.
of which direction I seek. Tell me in which direction will be force of friction. Think about it, dear. There is no slipping. Told by author, there is no slipping between this capital M, which is fair, and this capital M, which is plank. There is no slipping. Are you getting it?
Yes, sir.
Yes.
Yes,
So
sir.
what is backward?
So backwards.
Therefore, what is the implied meaning? What is the implied meaning? The implied meaning is sphere will roll without slipping on the plank, correct?
Yes, sir.
Yes, sir.
Sphere is this time to roll without slipping, but no more on ground, on the plank. Please be very careful of this question. It is a hand-picked question for you. A question of its own kind. Find here.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So F forward, you know masses, and you wrote acceleration. You said that F is acting, normal, mg, they are acting. We are hooked by Fs. Tell me, dear, anyone who
So-
can help me on Fs? Fs, why did I say you know that
So
very
will
well?
it be
Correct?
backwards? Yeah.
Fs will act in the backwards direction, right, dear? Why?
Yes,
sir.
Yes,
Because
sir.
just think
the
of
force
it,
is in
dear.
the forward
I will not
direction.
keep on repeating, dear. I have told you now, application is for you. Try understand.
Yes,
We
sir.
have seen for
Yes,
this
sir.
case. I told you, right here. Can you
Yes,
recollect?
sir.
What did I tell you? I told you then that 2 by 5 into R. If 2 by 5 mr square is moment of inertia, then 2 by 5 into R, if you apply at, then there will be no friction, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Above it, if you apply
There will
above
be.
it, then
There
friction
will
will
be.
act in which direction, and below
So,
it, then friction will act in which direction. Please be very careful, class. I am repeating it for you. F over here, this is a sphere to us. And I know that if on the sphere I apply force here, only then there will be no reaction, therefore no Fs, correct?
yes,
Yes,
sir.
sir.
Yes,
But
sir.
if I apply below, if I apply force below, then friction will act in the
Forward.
backward direction, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Above. If I apply above, then friction will act in
Forward.
forward direction. Got it, yeah?
Yes,
Yes,
sir.
sir.
Careful,
Yes,
got
sir.
it, yeah?
Yes, sir.
Yes, sir.
Okay. So you got now the direction of friction, yes or no?
Yes,
Yes.
sir.
Yes, sir.
All of you, can you relate to
Yes,
this?
sir.
Yes, sir.
Yes, sir.
Okay, so remember this point 0. Below it, backwards. Above it, forwards.
Forwards.
Clear here?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. In ring, you apply here. For ring, this should be R, correct? 2 by
Yes,
5
sir.
R for ring MR is square, so this will be R. So when you apply over here, then there will be no friction acting, correct?
Yes,
Yes,
Because
sir.
who?
Yes, sir.
These. Correct?
Yes,
Yes,
sir.
sir.
Below, if you apply then, if you apply
Then
goes
well,
below, come on, tell me,
There'll be friction.
then there will act friction. Which direction?
One second.
Which direction? Now relate, please. Now relate, class. This will not be taught anywhere. You have to apply your faculties and relate, please.
So
You
forward.
know what did I tell you? You have to apply the same over here. Tell me, dear, from where do we get this number? It doesn't come from thin air. Does it come from anywhere? All of a
No.
sudden, no, it didn't pop any all of a sudden. 2 by 5 R,
So-
MR is square, we know, and from there we are getting. Similarly, over here, we know moment of inertia is MR square. From there we get R, correct?
Yes,
Yes, sir.
sir.
Yes,
Okay. Tell me, if I apply over here, there will be no friction. Okay, agree. But if I apply below it, then
It will be in the
then they will.
backward direction.
friction will act in which direction? Of course, there will be friction. In which direction? You have to relate direction from here. Come on, tell me.
Is it backward?
Backwards, correct.
Yeah.
Which direction? Backward direction. Fine. Can it
Yes.
ever
Yes.
act on the forward direction if you apply force this way?
Sir, I don't get your question. Sir?
Can ever on the ring it act in the forward direction if you apply force this way? Is it possible on ring to act friction in the forward direction at point of contact?
Yeah. So then it act in forward direction.
When will it act in forward direction? What
When
are you saying, Amrish? You're not getting my question here. I asked, is
No,
it
sir, it won't
possible
act in forward
on the
direction.
ring if I apply force here or anywhere, you allow me and I apply anywhere on the body. I apply anywhere force on the body. Is it possible for any
No.
point of application for friction to show itself at point of contact acting in the forward direction? Yes or no?
No, sir.
No, yeah.
No.
no, sir.
Why no?
So because the um
Yes, Vedant,
the
trying.
force,
Why
yeah,
no?
sir. So because the force application of force can't be below if it is below moment of inertia I, then it will act always backward.
So it can never be above it, correct?
Never be,
Yeah?
yeah. Yes, sir.
Yeah. If you
It
are
can never
above,
be above the radius.
then you're going off the body, correct? Yeah.
Yeah, yes, sir.
So please remember, very good, Vedant. So what do we get to see from here? Below this point, if I am, then it will act as if it is translating. So force of friction backwards. Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
Above this point, if I am, then force of friction at point of contact in which direction? Forward.
Forward.
Clear?
Yes,
Am I clear
sir.
to
Yes.
all of you on this?
Yes, sir.
Yes, sir.
Okay. If I'm clear, then you are in agreement with force of friction acting in which direction here? Tell me. Everything the same. From here I pick and ask you. I want it to
The
roll and
forward
rotate.
direction.
Yeah. Force of friction will act in which direction? Come on, tell me, dear.
Forward direction.
Forward.
Forward
Forward
direction.
direction.
Force of friction will act in the forward direction. Force of friction will act in the forward direction. Am I clear with this concept, first class?
Yes, sir.
Yes, sir.
Yes.
Okay, so this is very important for us to analyze, and we have analyzed it. Force of friction will act, of course, will act, and will act in forward direction. So let us show it along. This is forward direction, force of friction Fs. Fine, class?
Yes,
Yes,
sir.
Yes,
sir.
And this is for which body? This
So
is
this
for
was
which
sphere.
body?
sir.
This is for sphere, correct?
Fair. Yes, sir.
Sir.
Yes, sir.
These are the forces acting on sphere, not the plank, correct? On
Yes,
plank,
sir.
Fs will act in the backward direction, right? Yeah.
Yes, sir.
Yes, sir.
Yes,
On
sir.
plank, Fs will act in which direction?
Backward
Backward
direction.
direction. Find yeah.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So are these the only forces acting on sphere? You will say yes, these are the ones. But when seen from Earth, these are the ones subject to the condition you are viewing from Earth, correct?
Yes, sir.
Yes, sir.
But when you are viewing from Earth, then this point will not be at rest. This point will be moving along with Planck, correct?
Yes, sir.
Yes, sir.
So you
Yes,
can
sir.
solve from Earth frame as well, but easier is for me to place myself on the Planck. Right here,
Yes, sir.
where am I?
Yes,
Where
sir.
Yes,
am
sir.
I placing myself? I'm placing myself on the Planck. Clear?
Yes, sir.
Yes, sir.
Yes,
I
sir.
place myself on the Planck, then I'm in a frame which is non-inertial.
Oh, yeah. Yes, sir.
Yes,
Right?
sir.
I'm in a
Yes, sir.
frame which is non-inertial. Now I'm on the Planck. Can you realize it?
Yes, sir.
Yes, sir.
Now I'm on the Planck, and
Yes, sir.
Planck is not at rest. Planck is accelerating. Can you realize that even?
Yes, sir.
So
Yes,
if
sir.
the Planck is accelerating, what we are to say? We are to say that we are on a frame which in turn is accelerating, correct?
Yes, sir.
Yes,
And if
sir.
the frame is accelerating, then I have to factor in pseudo force, correct?
Yes, sir.
Yes, sir.
I have to factor in pseudo force. There is no way out. So
Yes,
what
sir.
I say, there will be pseudo force, and pseudo force, passes through center of mass and in the direction opposite to the acceleration of frame, right?
Yes, sir.
Yes, sir.
Yes.
So frame, which is the frame to me, Planck is the frame to me, right, Krish?
Yes, sir.
And Planck can move in which direction, Krish? Think about it. Force of friction on Planck is acting in which direction? Backwards? On Planck. Agreed or not?
Yes, sir. Yes,
Yes,
sir.
sir.
Planck, it is acting in the backward direction. So force
sir.
of friction is in backward direction, and that is the only horizontal force, correct?
Yes, sir.
Yes, sir.
Yes, sir.
So owing to this force, Planck will start moving backwards with what acceleration? Fs by m, right?
Yes, sir.
Yes, sir.
And if that's the case, then I'm in a frame which is accelerating backwards with an acceleration Fs by m, correct?
Yes, sir.
Yes, sir.
Yes, sir.
So being on that frame, if I am to write equation of motion for sphere, I will incorporate pseudo force as well, correct?
Yes, sir.
Yeah. Yes,
Yes,
sir.
sir.
Force will be what on quantum or empirically? Empirically, it will be mass, capital M is the mass. So empirically, it will be capital M the mass multiplied with acceleration, correct?
Yes,
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 sir.
sir.
And since I have taken mass the same, so you are to eventuate it to Fs. If mass is different, accordingly you will get different value. Find yeah.
Yes,
Yes,
sir.
sir.
Yes.
Size of Fs, half of Fs, whatever it is. It fine?
Yes,
Yes,
sir.
sir.
Okay. Now you are in entirety to see the picture full sum you can view. And please view it full sum. How many forces as per you being on plan put? I am put on the plan. How many forces do I see it being subjected to? So the sphere is subjected to in the horizontal direction F, and Fs at the center, and Fs at the bottom. Correct?
Yes, sir.
Yes,
Very
sir.
good.
Yeah.
Okay. Now we can read for motion of system taken. Fine.
Yes, sir.
Yes, sir.
Now we will read for translational and rotational aspect. Can anyone tell me what about translational aspect? What about rotational aspect of this sphere? F plus twice of Fs is equal to mass into acceleration, correct?
Yes, sir. Yeah.
F plus twice of Fs is equal to what to it? Mass into
Mass into acceleration.
correct?
Yes,
Yes,
sir.
sir.
And rotational aspect, Fr minus Fsr.
So won't pseudo force also be there in the translation aspect?
Yes, it is
It
there.
is
That
2F.
is of Fs, Nadia.
Okay, yes, sir.
F plus
Yes.
twice of Fs. One Fs this, the other Fs this.
Yes, sir.
F plus twice of Fs is equal to mass into acceleration. Where are you, Krish?
Yes, sir. Yes, sir.
F, Fs and Fs. So F plus twice of Fs is equal to mass into acceleration. One equation, correct?
Yes, sir.
And the other equation will be Fs into R minus F into R. Or F into R minus Fs into R is equal to I naught into alpha, correct?
Yes, sir.
Yes, sir.
And third equation, A equal to R alpha.
R.
Find here.
Yes,
Yes,
sir.
sir.
Third equation, A equal to R alpha.
R alpha.
From these equations, you can easily find everything related to A and alpha as I is known to you, correct? How many unknowns?
Yes.
How many
Yes,
unknowns?
sir.
We
So
don't know
you
alpha,
have
we don't know A, we don't know alpha, correct?
Yeah, sir. 3
Yes,
unknowns.
sir.
Three unknowns and three equations. We can solve it, correct? Yeah.
Yes,
yes,
sir.
sir.
Yes, sir.
Sure.
Yes,
Yes.
sir.
Yes, sir.
And then we can get from there whatever the question is asking for. Fine, do check this question. This is an important question, class. Take your time. Take your time to be through. If you have anything to ask, please feel free to ask.
I got it.
Got it here?
Yes, sir.
Yes, sir.
Fs can be ambiguous. I repeat, Fs can be ambiguous. Equation, of course, you can write. You know how to write equations. The only contention over here will be to decide on direction of Fs. Yes or no?
Yes, sir.
Yes, sir.
So that is what is to decide. See, if Fs acts backwards, let's say there is a case in which Fs is acting backwards. Find yeah?
Yes,
Yes,
sir.
sir.
So if Fs acts backwards, then this plank will move forward, correct?
Yes,
And
sir.
then
Yes,
pseudo
sir.
will act in which direction? Backwards, correct?
Yes, sir.
Yes, sir.
And your equation will be F minus Fs
Fs.
plus Fs is equal to Ma, correct?
Yes,
Yeah.
sir.
Yes.
Think about, I'm getting you the other case. Case number 2, because I'll show you that Fs can change, and you know that very well, by the way. But I'll take an example as well to show that Fs can change its direction. Now let's say Fs is acting in the backward direction. Fs is acting in the backward direction on sphere. Then on plank will act in the forward direction, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Then we are in a frame. Which is accelerating forward.
Yes, sir.
Yes,
sir.
sir.
And on plank then I'll be in which frame? A frame which is accelerating forward, same yes or no?
Yes, sir.
Yes.
Yes, sir.
And if that frame is accelerating forward, pseudo force will be in which direction on the sphere? Backwards?
Backwards.
Yes.
Yes, sir.
Okay. So in that case, pseudo force will be backwards and Fs will also be backwards, correct?
Yes,
Yes,
sir.
sir.
So what will my equation read then? F minus, where is it? See, this equation will not change. This equation will not change.
Yes,
Because
sir.
pseudo-force is not put weak translational equation. Tell me why. Why pseudo-force doesn't have any trucks with translational equation? Because you are calculating translational equation from where? From center of mass, correct?
Is it rotational equation?
Yes,
Correct
sir.
or not? Yeah.
Yes, sir. Yes, sir.
And pseudo-force
Yes,
passes
sir.
through center of mass, correct?
Yes, sir.
Yes, sir.
So pseudo-force will not have any effect on your rotational equation. Getting it?
Yes,
Yes,
sir.
sir.
Yes, rotational equation. Pseudo-force will not have any effect on your rotational equation. When I say any, of course, it is subject to the condition V being at center of mass of sphere, correct?
Yes, sir.
Yes, sir.
We are at center of mass of sphere, and pseudo-force is always to pass through center of mass of a body. Therefore, rotational equation will see no change. It has got no trucks with pseudo-force. Am I clear?
Yes, sir.
Yes.
But translational, of course, is to change, correct?
Yes, sir.
Yes. Yes,
In
sir.
one case, you get F plus twice of Fs is equal to mass into acceleration. In the other case, you can get F minus twice of Fs is equal to mass into acceleration. Clear?
Yes, sir.
Yes, sir.
Okay, that depends on direction of friction. All of you good with this question?
Yes, sir.
Yes, sir.
100%.
Okay, good enough. Fine. So we move to the last one, rotational mechanics. The question being, a rod of mass m and length L. A rod of mass m and length L is resting against a smooth wall, and smooth floor. A rod of mass m and length L is resting against a smooth wall and smooth floor. Find angle theta. Find angle theta at which a rod will leave in bracket break bracket close. Rod will leave the wall. Rod will leave the wall. Is it okay?
Yes, sir.
Yes, sir.
So there is a rod given to you of mass m length L, and we are to rest this rod against smooth wall and floor. The rod will start slipping as is given, correct, yeah?
Yes, sir.
Yes, sir.
Will start slipping, and the author is an ask on at what angle theta rod will make a departure from wall. When will it, for what angle theta it will break from wall? Given that initial value of theta is either alpha or 0, whichever you take. Find, yeah?
Yes,
So we were
sir.
supporting this rod and keeping the angle alpha when we thought of withdrawing the force of constraint. When we withdrew, we found the rod started slipping, and it slipped till angle theta when it broke from wall. Find, yeah?
Yes, sir.
What will be the angle theta is what author has asked when it breaks from wall. Okay, so we have to see this question in all its detail, every nuances, each and every part of it, So let us take it in piecemeals. Fine, dear?
Yes,
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 sir.
sir.
Okay. Because we have to look into the nitty-gritty of this question. It's a very important question. Okay. Tell me first things first. How many forces are to act on center of mass? How many forces are to act on center of mass? This is
mg.
center
So
of mass.
mg.
mg.
One is mg, of course. Mg will act in the direction I have taken downwards. Fine, taken. Mg shown. And you know that when I speak for center of mass, all the forces acting on the body are assumed to be acting at center of mass. Correct, yeah?
Yes,
Okay.
sir.
All the forces acting on the body are assumed to be acting at center of mass. So think of the forces acting on body, not only the ones which are to act at the center, not only the ones which are to act on the center, all the forces acting on the body.
So
Tell
then
me,
there
dear.
is so there's normal at the two ends.
What, dear?
So there is normal force at the two ends, no sir.
They are normal forces. One normal will be, as normal means normal to the surface in contact. Correct, Krish?
Yes, sir.
Yes, sir.
So one normal will be this to us, and the other normal will be this to us. Correct? So there are
Yes.
two normals acting, and they are also to be for center of mass motion, assumed to be acting at center of mass position. Correct?
Yes, sir.
Yes, sir.
Yes.
Any other force? If we are
So
looking
can
for,
there be?
say no.
So are we consider friction?
We are looking from Earth.
So do we consider friction?
Friction. Okay. There's smooth surface that are being told by the author, correct?
Okay.
Yes.
The surface is taking being smooth, what the author told you, perhaps. Correct, yeah?
Oh, sorry. Yes, sir. Yes, sir. Yes, I
There's
agree.
no friction present anywhere. So we restrict to these three forces, right, yeah?
Yes,
Oh,
sir.
yes, sir.
The forces acting on the rod taken. Good enough? Tell me then, what, according to you, I'm asking, so please be very careful. What, according to you, will be the coordinates of center of mass? Please read vis-a-vis frame that you are in. Please read it vis-a-vis frame that you are in. And as I told you, I'm going in piecemeals. I'm asking you questions which don't qualify and ask, yet I'm asking. So please don't fail me. What are the coordinates of center of mass? This one. Length of rod is L. Come on, tell me. X coordinate, Y coordinate.
Uh,
What will be its X coordinate? What Y? Quickly, dear. Not that difficult. Krish, Adesh, Vedant. Length is known to you. Total length is L. And I want center of mass. Therefore, I want this point coordinate. I want this point coordinate. So what I'm asking? I'm simply asking for how much will be this and how much this. It is no rocket science, is it?
oh, yes, sir. Yes, sir. 1 second.
Simple. I'm asking you about what will be this equal to and what this. You
Why?
can tell
Why?
me. This length
So
is
y coordinate is L cos theta.
okay. This will be L cos theta, dear. So this will be L minus L cos
L
theta,
minus
correct?
L cos theta.
Sorry.
Yeah, yes, sir.
L by 2. L by 2 minus L by 2 cos theta. Check it here. This is L by 2, correct?
Yes, sir.
Yes, sir.
So how much will this be?
Yeah.
L
L
by
minus.
Oh,
L
okay.
by 2
Yes, sir.
this one. This one will be L by 2 cos theta, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
And what about this one, this total? I want this. Please be careful. So I think L cos theta minus L by 2 cos theta, na?
Yes, sir. It's the other way around.
Yes, yes.
Yes,
So
sir.
it will be this point, this length. This length will be how much to us? This length total. Total is how much? L cos theta?
Yes,
Yes,
sir.
sir.
This is L cos theta. And how
Yes,
much is
sir.
this? L by 2 cos theta, correct?
Yes,
Yes.
sir.
Yes, sir.
So how much will this be? L cos
Cos
theta
theta.
minus L by 2 cos theta, correct?
Yes, sir.
Okay, so I write it down this way. Any problem? Check it out here.
No, sir.
No
And
problem,
write it
sir.
down, simplifying it as L by 2 cos theta.
Yes, sir.
Yes,
So
sir.
next one
Now about this
is
one.
The next one
L
is L into sine theta minus 1 by 2 sine theta.
minus L by
Okay.
2 sin.
That be L by 2
Minus
sin
L.
theta. Can you say that?
So L sine theta minus L by 2 sine theta.
So L sin theta minus L by 2
Yeah.
sin theta will get you L by 2 sin theta,
L
right?
by 2
Yeah.
sin theta. Yes, sir.
Yes, sir.
Okay, now I write the values. X coordinate L by 2 sin theta. Differentiate it. You get velocity. L by 2 cos theta into d theta by dt. Please be careful of differentiation. Very important this. Is it okay?
Yes,
Yes, sir.
sir.
Yes, sir.
Cos theta into d theta by dt. Then we differentiate it once more to get acceleration. Which component of acceleration? X component, correct?
Yes, sir.
Yes, sir.
Now please be careful again. L by 2 you can take out, bracket open. Cos theta differentiation will get you minus sin theta.
Minus sin theta.
Yes,
Yes,
sir.
sir.
Okay, and minus sin theta will not suffice alone. Minus sin theta into d theta by dt, correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
D theta by dt and this d theta by dt will get you d theta by dt squared. Correct, yeah?
Yes,
Yes,
sir.
sir. Alpha
Not
square.
complete as yet. Now what will
Yes,
you
sir.
do? You will keep cos theta as it is, correct?
Yes, sir.
Yeah, yes, sir.
Getting it here, getting it all of you.
Yes, sir. Yes,
Getting
sir.
it, sir.
Uniform. So now cos theta as it is and differentiation of d theta by dt. Find here.
Sir.
Yes, sir.
Okay, get it, let it sink. Let it sink. Find all of you.
Yes, sir.
Okay, good enough. Can you also help me with AY then? This one. What will I do? I'll first differentiate to get BY and then finally to get AY. Correct, yeah?
Yes,
Yes,
sir.
sir.
Yes,
We
sir.
can get into steps that as well. Can we get into steps or not? Think about it. So AY I leave for you because I will not require AY, but I'll ask you the other day what was AY. Find yeah?
Yes,
Yes,
sir.
sir.
Okay. Now in my AX, why I was hell-bent on getting AX? Because author has asked me when N1 will become 0, correct?
Yes,
What
sir.
did author ask? When will N1 become 0, correct?
Yes, sir.
Yes, sir.
N1 as per Newton's second law of motion is mass into AX. Agreed. Agreed. Tell me
Yes,
yes.
sir.
Yes, sir. Yes, sir.
Newton's
Yeah.
second law of motion, normal. Center of mass motion here. Normal is the only force in the horizontal direction,
Yes,
correct?
sir. Yes, sir.
N1.
Yes.
Yes, sir.
What is equal to what to us? Mass into acceleration of center of mass, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. And normal will become 0 when AX becomes 0, correct?
Yes, sir.
Yes, sir.
So normal N1 will become 0 when AX becomes 0. So my question boils down on finding when will AX become 0, correct?
Yes,
Right,
sir.
sir.
Yes, sir.
And AX can become 0 when sin theta d theta by dt square is equal to cos theta d square theta by dt square, correct?
Yes, sir.
Yes.
So with further precision, if you are to come here, you will get to the point where you are requiring d theta by dt and d square theta by dt square. You are in
Yes.
requirement of these two equations, correct?
Yes, sir.
Yes,
Yes,
What
sir.
sir.
is theta by dt and what will be d square theta by dt square, correct? Yeah. If I get you what is theta by dt and what is d square theta by dt square, you can get me theta, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
So let us try to figure that out. And for that, As I have told you always, there are two equations. One is translational, the other is rotational. But you also got evolved to rotational can also be found by energy equation, correct?
Yes, sir.
Yes, sir.
So for energy, I seek the position of instantaneous center of rotation, any one of you.
Sir, it's
We draw the perpendicular distance from N to an N1.
Yeah, we solved this question long back and you will not fail me on it. Tell me where will I ICR? How will I find ICR for this orientation? Tell me.
So we draw perpendicular
So
from two velocities, that is from N to an N1 along those.
Yes, so one will be this here, correct?
Yes,
Yes,
sir.
yes,
sir.
sir.
And the other will be this one, correct?
Yes, sir.
Yes, sir.
This is ICR, correct? Yeah, instantaneous
Yes, sir.
rotation.
Yes, sir.
And what is the that I am going hyper hoopla about instantaneous center of rotation? Why I'm going gaga on instantaneous center of rotation, you know? Because you can write in one shot,
One shot.
energy as half IP into omega square, correct?
Yes, sir.
Correct, sir.
Yes, sir.
Okay, so that is what I stand gain. Therefore, I am going tom-tom about it. Tell me, what is initial energy when alpha is 0? Can I say minus of m, sorry, not minus, depends on where I'm taking this as 0 potential. So plus of mgl by 2, think about it.
Yes, sir.
Yeah, yes, sir.
Yeah, yes, sir. Yes, sir. Yes, sir.
Yes,
Yes,
sir.
sir.
So the rod sticks to the wall, clear here?
Yes, sir.
Yes, sir.
Where is my 0 potential? Here, correct?
Yes, sir.
Yes, sir.
I have taken it to be here, fine?
Yes, sir.
Then
Yes,
where is
sir.
center of mass? Above of it. By what
Yeah,
distance?
yes, sir.
By 2, correct?
Yes, sir.
Yes,
Yeah.
sir.
So what will be potential energy equation to read? Potential energy equation to read will be mgl by 2, right?
Right, sir.
Yes, sir.
And kinetic energy?
So, won't it be?
Kinetic energy at that point will be 0. Why?
Yeah. So, because it's
What
not
is not
motion.
No motion. So not in motion.
Okay, body was not in motion. So kinetic energy at that time, 0, correct?
Yeah,
Yes,
yes.
sir.
Yes, sir.
Then it slide, omega, it is developing omega, is increasing as well, fine, good enough. It comes to an angle alpha. What is potential energy now? What distance? 0 del by 2 cos theta, correct?
Yes,
What will
sir.
it be? mg L by 2 cos theta, same yes or no?
Yes, sir.
And kinetic in one shot. Kinetic
Half.
in one shot, tell me, half
So half
IP omega square.
IP
IP
into
omega.
omega square, correct?
Yes,
Yes,
sir.
sir.
Now IP is also very simple to know. Tell me why did I say so?
Sir, I have a doubt.
Yeah, tell me.
So mg L by 2 cos theta.
Hmm.
Sir, is that when the angle is theta, right?
Yes.
So are you sure it's L by 2 cos theta? Isn't it L cos theta?
Okay.
So it's L cos theta, right?
Because this total is L cos theta, na?
Yes,
Center
sir.
of mass we take, na dear?
Oh, sorry, sir. Sorry. I was little. Yeah, got it.
Now, IP into omega square. Now we were at IP, right here?
Uh, yes, sir.
We were at IP. We were to find IP, correct?
Yes, sir.
Yes, sir.
Tell me, look at the figure and tell me, is this to you a rectangle?
Yes,
sir.
sir.
Or no?
Yes, sir.
Yes, sir.
Angle. This length is L, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
This will also be L, correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
And in rectangle, diagonals are to bisect, correct?
Yes, sir.
Yes, sir.
How much will be this? L by 2, correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. If that is L by 2, you know IP. Someone, quickly. Can you tell me IP? Can you tell me IP of rod? Can you tell me IP of rod? Any one of you, volunteer please. IP of rod. P is this point. P is this point.
So will it be ml square by 12 plus ml by 2 whole square?
Very good. Correct, Krish. ml square by 12, which is I naught.
Yes,
I'm
sir.
using parallel axial theorem. Chris has used parallel
Yes,
axial
sir.
theorem. First, he
Yes, sir.
calculated our center of mass. He got ml square by 12.
ML square by
And then
12.
what
Yes,
did
sir.
he used ml by 2 whole square, correct?
Yes, sir.
Yes, sir.
Yes, sir.
ml square by 12 plus ml square by 4. How much? ml square by 3, correct? Yeah. Check
Yes,
once.
sir.
Yes, sir.
Yes, sir.
Yes,
Square
sir.
by 12 plus ml square by 4. ml square by 3, correct? Am I right? Correct? Yeah.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so we get the equation. I write over here. This one.
Yes, sir. Yes, sir.
Yes,
It
sir.
is visible.
So ML square by 3.
mg L by
L
2,
by 2.
1 minus cos theta. I take it to the other side, correct?
Yes,
Yes.
sir.
Yes, sir.
Is equal to half ml square by 3, right here?
Yes, sir.
Yes, sir.
Into d theta by dt whole square. Omega is nothing but d theta by dt. Check it.
Yes, sir.
Okay, omega is nothing but d theta by dt. Is rotating with an omega. I told you omega will remain same if you are on body or off body, except for one point. Correct, dear?
Yes, sir.
Yes, sir.
If you are off body, what you will written omega for the rod? D theta by dt only. Correct, dear?
Yes, sir.
Yes, sir. Yes, sir.
So we replace omega by d theta by dt. Now you got d theta by dt square, which you can replace here. Correct?
Yes,
Yeah,
sir.
yes, sir.
Yes, sir.
Not only that, when you will differentiate once, you will get d square theta by dt square as well.
Okay. Yes, sir. Yeah.
Yes, sir.
Differentiate, here you will get d theta by dt, here you will get twice of d theta by dt into d square theta by dt square, correct?
Sir.
Yes,
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 sir.
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 And d theta by dt, d by dt gone, correct?
Yes, sir.
So you'll get d
Yes,
square
sir.
theta by dt square. I'm repeating it and I'll solve it for you with your help. This is of import, very important question this. Okay, so let us get to the end of this question at least. Okay, look over here. This is now to be differentiated. mgl by 2, find here, bracket open, 0 minus
Yes.
sin theta into d theta by dt, fine.
Yes, sir.
Yes, sir.
Is equal to what to us? Half ml square by 3. Now this. Twice of d theta by dt into d square theta by dt square. Fine.
Yes, sir.
Yes, sir.
D theta by dt, d theta by dt gone. Okay. mgl by 2 minus is equal to ml square minus ml square by 6, so 3, 2 into 1, d square theta by dt square. Correct, yeah?
Yes, sir.
Yes, sir.
Check. Fine. Cos theta will get us plus, yeah?
No,
Cos theta
no.
minus
So-
theta.
What?
Minus
Yes, okay. Yes,
plus.
So minus, yeah.
yes, sir.
Okay.
Yours
Yes,
plus.
sir.
Right
Yes,
here.
sir. Yes, sir.
Now you got from here d square theta by dt square as ml gone, so 3 g by 6l. Is it so? Check once.
I got 3G by 2L.
The 3g by 12, sorry. 3g by 12. 3g
Yes,
by 12, right. So this is d square theta by dt square, fine.
Yes, sir.
And this will get you d theta by dt, fine.
Yes, sir.
Now place the value and get me the final answer. At what theta ax will become 0? Please do the info. At what theta ax will become 0? Get me now from there. Please just place it. Place it here, and get me the value. You please do the needful. Ask me if anything is not understood. Please feel free asking me any number of time you deem, but get me the answer. And please reserve your answer. I'll go individual. I'm asking you to place the value of d theta by dt whole square here and d square theta dt square here from whatever we have got. They are just to be placed and equal to 0. So next will be 0. ROM will not get over here. As didn't get over LOM, as didn't get over work power energy, rotational mechanics also will not get over. Firstly, you are to get done with Irido and then you are to get done with the questions which I am having with me. Correct, yeah?
Yes, sir.
Yes,
A
sir.
good number of questions with me as well, but I'm awaiting your response to the ones which I have already uploaded. Fine, yeah? Once you get me
Yes.
response against those questions, then you are to get more than what your appetite can ever handle. You will be getting good gamut of questions. Fine, yeah?
Yes, sir.
Yes.
All very good questions to solve for advanced IIT. Tell me when will N1 become 0? Of course, when AX becomes 0. And AX becomes 0 when the bracketed term becomes 0, this bracket. Just place, keep your patience, and strike off the commons, simplify, you get a very amicable solution. If done, please register by saying yes.
Sir, I'm getting something with lot
Okay,
of.
done you mean to say, correct? Yeah. What did you do, Krish? You replaced d square theta dt square by 3g by 2l, correct?
Yes, sir. Yeah.
And then you have replaced d theta by dt whole square from here, which will get
Yes.
you 6gl, 6g by l, isn't it?
Sir,
6g
I
by
got.
l 1 minus cos theta, correct?
Sir, not
I got
the
something
3g
different.
by L into 1 minus
So
cos theta.
theta by dt whole square.
Yes, sir. I
Theta
got
by
the same
dt whole
shit.
square is replaced by 6g by l 1 minus cos theta, correct?
So 3g by
Sir,
L, sir.
I'm getting
3 of the
3g into 1 minus cos theta by L.
Yes, sir.
So Adesh has come up with some answer. Krish, you are also up with some answer, correct?
So,
Yes, sir.
Okay, Vedant, what is your case? Did you simplify?
yes, sir. So,
Okay, fine. I go to Krish first. Krish, what is your answer? Tell me, dear.
Sir, I
One
got
line.
cos theta divided by 2 is equal to sin theta into 1 minus cos theta.
Cos theta divided by 2 is equal to sin theta into.
1 minus cos theta.
So cos you take common, no, dear. You get me in terms of cos or sin, whatever you're getting.
Yes.
Or tan. Okay, Adesh, what is your answer?
Sir, I got the same. Krish, did you get what do you call d theta by dt square is 3g into 1 minus cos theta by L?
Whatever is
3g,
being
yeah.
required, I have shown already to you. Now you are only to place the values. Look over here. Sin theta. Now d theta by dt whole square, how much will it be? 3g, 3g by L, correct? Into 1
yes, sir.
minus cos theta. That is to
Yes.
me d theta by dt whole square. 3g by from here. 3g by L 1 minus cos theta. Okay, sin theta goes to that side. Is equal to cos theta as it is. Now d square theta dt square is how much to us? 3g by twice L. Right here?
Yes,
Yes, sir.
sir.
Yes,
Subject
sir.
x being 0. Why x being 0? Because I'm assuming that at this theta, n1 becomes 0, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
From here, what you get? What was so difficult about it, dear? 3g gone, 3g gone, L gone, L gone. What do we get? 1 minus cos theta is equal to cos theta by 2.
By 2.
There is sin theta there also, sir.
Where is sin theta, dear?
So here, there is
So
a
there's
sin.
a sin theta.
Oh,
Sin
sorry.
theta here before.
1 minus, sorry. 1 minus cos theta, what is it? This sin
Yes,
theta,
sir.
I will write sin theta as well.
Yes, sir.
This is 3g d square theta dt square, how much we got?
Sir, this one. 3g by 2l.
This sin theta here. Sin theta, right?
Yes,
sir.
sir.
Yes, sir.
Okay, sine theta minus of sine theta into d square theta dt square. Where is d square theta dt square? D square theta dt square. What do we get when we differentiate it?
It's already there, sir. 3g by 12.
Ah, where is it?
It's already replaced. This is the last equation.
Like 12 into sine theta also we should get, na? Into sine theta also we should get somewhere. I have differentiated this, right?
Sir, sine theta is coming from ax's value. Sir, ax is equal to minus sine theta.
Okay, that I understood. D square theta dt square, could you please cross check? D square theta dt square will come with sine theta here, yeah. Check once. Sine theta, cos theta, this sine theta I missed, na? Sine theta into d theta by dt, na?
Yes,
One
sir.
second.
Differentiate this and then check. To get d square theta dt square, what will you be getting? One will be sine theta into d theta by dt. Differentiate and then you will get. Now I missed sine theta here.
Okay.
dg by 12 into sine theta it should be. Check.
Yeah. Yes, sir. Yeah.
Differentiate this here, you will be getting this as 0 and this will be sine theta into d theta by dt.
Yes, sir. Yes, sir. You get sine theta.
Yes,
Yeah.
sir. Yeah, yes,
Nothing
sir.
but sine theta, fine.
Yes, sir.
Yes,
Yes,
sir.
I got it.
Yeah, 1 second. So yes.
Correct? Check. D square theta dt square 3g by 12 into sine theta, correct? Yeah.
Yeah. Yes, sir.
Yes, sir.
Okay,
Yes,
sine theta cannot be equal to sine theta. There is no sine theta here. Right?
yes,
Yes,
sir.
sir.
Yeah.
What we get? Final answer, please.
Sir, cos theta is equal to 2 by 3.
Yes, cos theta is equal to 2 by 3. That is what we get. Cos theta is equal to 2 by 3. But this is for initial alpha being 0, correct?
Yes, sir.
Yes, sir.
Yes, sir.
When initial alpha we took 0. If initial alpha is not 0 given to you as alpha, then you will get it as cos theta minus cos alpha. Correct, yeah?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, please correct this point. I missed sine theta over here. Fine, yeah. It will be sine theta.
Yes,
Can
sir.
we or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, as I have missed over here sine theta. Fine. So
Yes,
this is
sir.
the
Yes.
question which I wanted to culminate it with. There are many questions still coming. Please be very off solving. I will do along.
Yes, sir.
Okay? You
Yes, sir.
won't get time. You won't get time. Let me be very assertive on it. It is not that now you are hooked and later you will have luxury on time. If it is now that you are in luxury of time. Is it okay? So please
Yes,
solve questions.
Yes, sir. Sir, one more thing, sir. Sir, can you take one class on logarithms?
Log mathematics.
Sir, for physics, because in Ireland, right, they've taught in a physics portion also, log.
Ah, yeah, that is mathematical tool we
Oh, okay,
use. I
fine.
have log of 1 plus
Oh.
x expansion of it. 1
Alright.
plus x, 1 minus x. We'll take it, no issue. Log 1 plus x in physics is not very frequented, but there is an ask on log of 1 plus x expansion or binomial expansion. So those we can see. No issue. How
Yes,
you
sir. Sir, and one more thing. Sir, did one of my friends contact you, Reshwar?
Nobody did
Oh,
contact.
so he might contact you. I've given him your number.
Okay, no issue. Okay, thank you, Adesh. Thank you, all of you.
Thank you,
Thank you,
sir.
sir.
Okay.